So yeah, hello everyone. I hope I'm audible and visible. So let's wait for 5 to 10 minutes so that everyone can join this session. So yeah, hello everyone. Let's start the session. I hope I am audible and visible. Can anyone confirm it? Okay, a very good evening and warm welcome to all of you. My name is Pooja Verma. I am PMRF Research Scholar from IIT Kharagpur, and instructor for this course is Professor Shamal Das Mandal, Advanced Technology Development Center, IIT Kharagpur. This is a week 6 live interactive session of signal processing techniques and its applications, where we will go through some assignment questions which is very similar to your assignment problem. Okay, so you can use chat box for asking and interacting. And also I would like to suggest to please carry one calculator, so it is helpful. And the content questions or questions related to this is two-dimensional discrete Fourier transform, discrete cosine transform, frequency analysis of long signals using DFT, and short-time Fourier transform. So here we will go, first we will go through some conceptual and formulas. So it will be very much helpful during our problem solving session. Okay, so the first topic for this week is the two-dimensional discrete Fourier transform. So what is it two? Already we have gone through the DFT, that is a one-dimensional signal. It is used for signals, and now for two-dimensional. So the two-dimensional signal is an image in a common or in a general. So if you are seeing an image like this, in order to perform any operation on the image, first we will convert it into a gray level image. Then it must be translated or in a pixel label, and that pixel is represented in the two terms I, x and y. Any image can be represented in the x direction and y direction, and image is represented in the terms of matrix. Okay, so for RGB image, so there are three values for I, R, G and P. It is for R, G and P. Okay, so normally image is performed on a special domain. So what is a special domain? So in the special domain, we directly manipulate pixels or directly perform operations on a pixel. Okay, so whatever image we are getting, first we are going to transform in the matrix, then apply some transformation or operation R, then whatever operation has been performed, then we have to inverse transform in the special domain. Okay, so whatever image we are getting, first we are going to transform it in a special domain, then perform some operations on that domain, then we again inverse transform in the special domain. Okay, so the two-dimensional discrete Fourier transform is represented by f of kl is equal to summation m is equal to 0 to m minus 1 and summation n is equal to 0 to n minus 1 in both the direction m and n. Mn, where mn f of mn is the original signal. F of mn e to the power minus j 2 pi k by m plus l by n, capital N into n. Okay, this is a DFT of a two-dimensional discrete Fourier transform. And in order to find out the inverse signal, so inverse DFT of two-dimensional discrete Fourier transform is can be find out is f of mn is equal to 1 by mn, capital M and n, where mn is the finite duration signal or finite duration pixels. And here also summation k is equal to 0 to m minus 1 and l summation L is equal to 0 to n minus 1 f of kl e to the power j 2 pi k by m plus L by capital N. Okay, so what is the disadvantages of DFT? So whenever we are going to solve, so you have seen the complexity related to the one dimensional signal, that is very much complex for addition and multiplication. We need n plus 1 number of additions and n square complex multiplication. And if we are going to perform in the two dimensional signal, then it will be the very complex, because we have to perform in both the directions. Okay, so it is a very complex and it has a poor energy compaction. So what is the energy compaction? Energy compaction is the ability to pack the energy of the spatial sequence into as a few frequency coefficients as possible. So it is pack the energy in the spatial domain or spatial sequence or pixels. Energy is packed as a few frequency component. Only some frequency coefficients will be packed in the spatial domain. And what is the application where we use two-dimensional signals or image? In image compression, we use two-dimensional discrete Fourier transform. Okay. So next is a discrete cosine transform. So discrete cosine transform is nothing but it is a part of a discrete Fourier transform. Just we are taking the real part of the discrete Fourier transform. So it is real and it has better energy compaction. So here we are eliminating the imaginary part, so it performs better. There are various versions available of DCT, that is DCT1, DCT2, DCT3 and DCT4, but most popular DCT is DCT2. So what is the formula of DCT? So DCT is represented for one dimensional signal Cx of k is equal to summation n is equal to 0 to n minus 1 to x of n cos pi by 2n k 2n plus 1 for finite duration signal, that is 0 to k varies 0 to n and 0 for otherwise. And in order to find out the inverse DFT, we will get from this formula, that is 1 by n summation k varies 0 to n minus 1 w of k cx k cos pi by 2 capital N k 2n plus 1 for n varies 0 to n and for otherwise it is 0, where w of k is 1 by 2 for k is equal to 0 and 1 for k varies 1 to n. So the one dimensional DCT used for signals, if we want to use for images, or as images is a two-dimensional signal, then the formula would look like this. C u of v for both the direction u and v, alpha u and alpha v, summation x varies 0 to n minus 1 and summation of y varies 0 to n minus 1 in the both direction f of xy cos pi to x plus 1 u divided by 2n cos pi 2y plus 1 v divided by 2 of capital 1, where u and v varies 0 to n minus 1 and alpha u and alpha v we can get from this formula, where it may vary. Here it is given, but we can take any value. It depends on question. So for u is equal to 0, it is root 1 by n, and if u is not equal to 0, it is root 2 by n. And in order to find out the inverse two-dimensional DFT, that is f of x comma y summation u varies 0 to n minus 1 and summation v varies n minus 1 alpha u alpha v c u v cos pi 2x plus 1 u divided by 2 into capital N cos pi 2y plus 1 v divided by 2 capital N. Okay, this is just in our two-dimensional DCT formula. Now, the next topic of discussion is frequency domain analysis of a long signal using discrete Fourier transform. So let X of n denotes a long sequence. It is used in the speech signal or speech processing mainly, because there we are getting very long signal in order to find out the DFT, or in order to find out or do any operation on the speech signal. Then what we need to do, let X of n denote a long sequence to be analyzed, limiting the duration of the sequence to taking L samples is equivalent to multiply X of n by rectangular window W of n of length L. Let there is a very long sequence, something like this. Now how we can analyze at 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 every instant of time or at a time, how we can analyze this long sequence? So what we are doing, we are taking any window function. There are different types of window function: rectangular window function, Hamming, Hanning, Bartlett. So what we are doing, we take any window function that for any finite duration and multiply with this signal, shift and multiply in order to find like a convolution. So we can analyze at every instant of time. Okay, so it is represented by x cap of n is equal to x of n w of n, where w of n is a window function, and this window function can be any, where w of n is equal to 1 for the duration 0 to L minus 1. This is a window function for a rectangular window. Okay, and if let the x of n is equal to cos omega naught n, then what will be the uh, function for the frequency analysis? That will be the x cap of n 1 by 2 w omega minus omega naught plus w omega plus omega naught. There are different type of things where we are just taking at every instant there is omega naught, and there is so omega minus omega naught. Okay, where w of omega is a DFT of the window function, that is represented as sine omega L divided by 2 divided by sine omega by 2 e to the power minus j omega L minus 1 divided by 2. Next, if we have x of n is equal to cos omega n plus cos omega 2n, there are two frequency components, omega 1 and omega 2. Then what is the DFT looks like? It will be looking like x cap of n omega is equal to 1 by 2 in brackets w omega minus omega 1 plus w omega minus omega 2 plus w omega plus omega 1 plus w omega plus omega 2. If omega 1 minus omega 2 is less than or equal to 2 pi by L, the two window function w omega minus omega 1 and w omega minus omega 2 are overlapped, and as a consequence, the two spectral lines x of n are not distinguishable. So in order to separate this signal, omega 1 minus omega 2 must be greater than equal to 2 pi by L. Okay. So next is the short time Fourier transform. So what is the short time Fourier transform? It is also for analysis of a long signal. Here STFT is a function of two variables. See, the time index n, which is discrete, and the frequency variable omega, which is continuous. Like this. This is the time index and it is a frequency variable for. So we analyze at every instant. So it is represented by x n comma omega. is equal to m varies from minus infinite to infinite x of m w n minus m e to the power minus j omega m or dtft of x of m w n minus of m. For analysis of a STFT, there are two different views. One is discrete Fourier transform view and another one is a filtering view. And for synthesis of STFT signal, it is there are two methods are available, that is filter bank summation method and overlap and add method. Okay. So now moving to the questions. So I will suggest you please carry one calculator so that we can solve the problem. Okay, so the first question is, image is an special domain signal, time domain signal, option C, both special and time domain signals, and option D, none of these. So what is an image? So already told you, image is represented in a special domain. Okay, so any image is represented in the matrix form, like I0, 0, 0, 1, 0, like this. And we directly perform manipulation on pixels. That is a spatial domain. So what is a spatial domain? A spatial domain, this is involves enhancing the image by manipulating individual pixels based on their spatial coordinates at a specific resolution. And the time domain, already you know that this analyzes the input signals depending on the waveform observed over a period of time. So image is an spatial domain signal. So correct option is option A. Okay. Okay, so moving to the next question. If f of kl is DFT of f of mn as shown in the equation below, then what will be the value of f of k plus m comma l plus n in terms of f of kl? So already you know that f of k comma l is represented as 1 by mn summation m varies 0 to m minus 1 and n varies 0 to n minus 1 f of mn e to the power minus j 2 pi in bracket k m divided by capital M plus L n divided by capital M. So already know that it is a periodicity property of a DFT signal or two-dimensional DFT signal. So how we can prove that? So in order to find out the answer, let's prove that. So if we add f of k plus m comma l plus n, then 1 by mn, m varies 0 to m minus 1, n varies 0 to n minus 1. So e to the power minus f of mn e to the power minus j 2 pi k plus m divided by m plus l plus n divided by n of n. So if we 1 by m and summation m is equal to 0 to m minus 1, n varies 0 to n minus 1, f of mn, if we can write it like this, k m divided by m plus l n divided by n. We have to, we can distribute this k by in both the terms, then it will come like m by m, m plus n by n, and so m will be cancelled and n will be cancelled. So this term e to the power minus j 2 pi m plus 1 only left, and this will be equal to 0. So only we will get this term, and this term is nothing but this term. So f of k plus m comma l plus n is equal to f of kl. So options are given as Option A, m n f of kl. Option B, f of kl. Option C, m square n square f of kl. Option D, m by n f of kl. So option D is the correct answer for this question. Okay. So are you getting this? Okay. So moving to the next question. What are the advantages of DCT over DFT? So what is the advantage of DCT? So already you know that DCT is a real, because we are removing the imaginary part of the DFT, then we will get the DCT, discrete cosine transform. And already told you it has a better energy compaction. So option A is it transmits whole set of coefficients. Option B, it is a complex and has poor energy compaction. And option C, it is a complex and provide good energy compaction. And option D, it is a real and has a better energy compaction. So DCT is not complex, DFT is complex and has low energy compaction. So option D is the correct one. It is real and has a better energy compaction. And also DFT provide discontinuity while analyzing the signal. It is like this. After n minus 1 signal, again it will start from this. Then so it is it provides discontinuity during the operation, while DCT provides continuous operation. So in DFT, since the signal is represented periodically, then when truncating representation coefficients, the signal will tend to lose its form. So it will start again from 0 and will continue. After n minus 1, it will lose the form. Then it will again start. While in DCT, due to continuous periodic structure, the signal can withstand relatively more coefficient truncated, but still keep the desired shape. It is also truncated, but from where it is in, it start from there also and complete the whole cycle. Okay, so the correct option for this question is it is real and has better energy compaction. Okay, so moving to the next question. Suppose an image is represented as I of x comma y. This is a matrix at it is given that any point of time it is converted to DCT using equation 2. This one is a equation 2. What is the value of C00 at C00 point? What is the value of that C00? And the equation is represented as C u comma b is equal to alpha u alpha b summation x varies 0 to n minus 1 and summation y is also varies 0 to n minus 1 I x comma y cos pi to x plus 1 u divided by 2 capital of N cos pi to y plus 1 b divided by 2 capital N. This is the equation 2. We need to find out from where u and v vary 0 to n minus 1 and alpha n is defined for n is equal to 0 root 1 by n, and for n is not equal to 0 it is defined for 2 root 2 divided by n. Okay, so let's solve this question. How we can solve? So first see what is n. So see in the matrix is a 3 cross 3 matrix, right? So it is n cross n, so n is 3. Okay, in order to find out n is equal to 3, in order to find out alpha u and alpha v, we can calculate from this equation. And u and v varies 0 to n minus 1, so 0 to 2. Okay, so we will see what will be the, it depends on value of u and v. Then we calculate from there. Okay, so let's solve this question. See what will we get. So please carry one calculator in order to solve this question. C u comma v. We can take in the slide, otherwise we can't able to calculate this. So we know that Cu comma V is alpha U alpha V summation x varies 0 to n minus 1 and y is also varies to n minus 1 I x comma y. Then after that I am writing here cos what is pi 2x plus 1 u divided by 2n, right? Cos pi 2y plus 1 divided by 2n, here v. So what value we need to find out? C 0 comma 0. So C 0 comma 0. So in the place of u and v, we need to put 0. So alpha 0 because v is also 0 and u is also 0. Summation x varies 0 to n minus 1. Here n is 3. So 3 minus 1 is 2. And y equal to 0, n minus 1, that is true. And I x comma y, here cos, here u is 0. So u, if we put here 0, so whole part will be 0 only, right? Because it is in multiplication. So cos 0. And here also v is 0. So this whole part will be 0 only. So can anyone tell me what is the value of cos of 0? Yeah, correct. And what is the value of alpha 0 and alpha? First we need to find out alpha 0. So that is 1 by root n for n is equal to 0, or you can say u or v is equal to 0, 1 by root n or 1 by root 1 by n. So root 1 is 1 only, so 1 by root 3, right? So now C 0 comma 0 alpha 0 is 1 by root 3 and alpha 0 again is 1 by root 3 and x is 0 to 2 and y is 0 to 2. I x comma y, this both are 1 only. So multiplication of 1 of ix comma y only. 1 by root 3 is 3. Then we will solve this summation 1 by 1. Okay, x of 0 varies 0 to 2. Then first we will put values of y, then come to the x. So I first x comma 0. First y varies 0 to 2. So first we need to put 0, then 1, then 2, right? So I x comma 0, x will be the constant here, plus it is summation, so summation of all the components. I x comma 1 plus I x comma 2. Okay, so now we will put the values of x as a summation. First we will put x is equal to 0 in all the in that sequence, in all the function, then 1, then 2. So I 0, first we are taking 0, so we'll put 0, then 1, then 2. So 0 comma 0 plus I 0 comma 1 plus I 0 comma 2, then 0 is done, then we will put I is equal to 1. I 1 comma 0 plus I 1 comma 1 plus I 1 comma 2. Then this part is over, then we will put x is equal to 2 in whole sequence. I 2 comma 0 plus I 2 comma 1 plus I 2 comma 2, and whole bracket is closed. Okay, so what is all those things? I comma 0 comma 0, I 0 comma 1 plus I 0 comma 2, 2 plus I 1 comma 0, I 1 1, I 1 2, I 2 0 2 1, and 2 2. So move to the question. If we put I here, see here, it is x direction, it is y direction. So it is 0 0 0 1 0 2, this 0 1 0 1 1 1 2 in both the directions. So what is this? This is the nothing but the summation of all the components of I. In order to find out c 0 comma 0, if we put all these things in this equation number 2, then it is nothing but the summation of all the components. So let's I 0 comma 0, what is the value of I 0 comma 0? That is 2, right? Then what is the value of I 0 comma 1? That is 1. What is the value of I 0 comma 2? That is 2. Plus similarly I 1 comma 0 is 1 plus 2 plus 1. Similarly, what is the value of I 2 comma 0, 2 comma 1, and 2 comma 2, 2 1 2. So 2 plus 1 plus 2, right? So what is the summation of all these components? 2 plus 1 3, 3 to 5, 5 3 8, 8 9, 9 to 11, 11 3 14. So 14 by 3. So let's see if the answer is matching with the options. So options are A 14 divided by 3, that is we will get. So correct option is A only. Okay. So the correct option is A only. So have you got this question? Can anyone answer? If you have any doubt, so let me ask. Have you got this question? Okay. Okay, good. Yes, sir. Okay. So moving to the next question. So yeah, a signal xn of e to the power j omega is the STFT of a signal xn of n using Hamming window W of n. Determine the minimum frequency sampling rate where length of a window n of W is equal to 100 samples and f of s is 10,000 hertz. Okay, so how we will solve this question? So already you know that minimum sampling rate. So in order to find out the minimum sampling rate of a signal in STFT, that minimum sampling rate is defined by SR is Fs divided by NW or length of a window function. So Fs is given is 10,000 hertz and NW is given 100 samples. So we will get here only 100 hertz. Okay, this is in hertz, so only hertz. Okay, so in order to find out the minimum sampling rate of any signal, the sampling rate is defined by the sampling frequency divided by the window length. Okay, so the correct option is A only, that is 100 hertz. Okay, so can we move to the next question? Have you got this question? Okay, moving to the next question. So reduction of the side lobes of a window is obtained by option A, decreasing the width of the main lobe of a window. Option B, decreasing the amplitude of the main lobe of the window. Option C, increasing the width of the main lobe of the window. And option D is none of these. So would you like to answer this question? At least try. For this question already you have gone through so many times in the lecture. Okay, so reduction of the side lobes of a window is obtained by how we can reduce the side lobes of any window function. Already I think in the lecture video you have gone through the different types of window functions, that is rectangular, Hamming, Bartlett, and other windows are also there. Their side lobes and their frequency domain you must be seen that. So the reduction of the side lobes in a window is obtained at the expense of an increase in the width of the main lobe. If we increase the width of the main lobe, then this is, if we increase, this is the main lobe and this one is a side lobe. So how we can reduce this? If we increase the main lobe width, then the side lobe must be reduced or decreased, and hence loss, but in the cost of loss of in the frequency resolution, we can get less resolution. Okay, so the correct option is increasing the width of the main lobe of a window. Okay, so correct option is C. Okay, moving to the next question. A signal xnk is the STFT of a signal xn of n. If the length of the DFT used is 1024, determine the frequency resolution where the sampling frequency f of s is equal to 10 kHz. So already you know that, I think. The length of the DFT is 1024 and the sampling frequency is given as is equal to 10 kilohertz. Okay, so the frequency resolution, I am writing it in the short form of FR, is, what is it? The formula for finding out the frequency resolution, that is Fs divided by length of DFT, that is N. Or if the window function, then the length of that window function. Okay, so Fs is given 10 kilohertz, or you can say 10,000, and divided by 1024. Okay, so let's see which one is the correct option. That is 1024 divided by 1000. Option B is 1024 divided by 10,000. That is wrong. This is one is opposite. And option C, 1000 divided by 1024. And option D is 10,000 divided by 1024. So correct option will be 10,024. 10,000 divided by 1024. Correct option is option D. Okay. Okay. So have you got this question? We can move to the next question. Okay. So moving to the next question. The next question is, select the purpose of the short time Fourier transform. What is the purpose of STFT? Option A. The STFT is used to find out the DFT of the signal with very few data samples. So can we go through this? The STFT is used to find out the DFT of the signal with very few data samples. No, the STFT is used to determine how the spectral content of a signal changes with time. So what we are going to analyze with the STFT? So STFT, we are saying that how the content that that is variation will change with the time. So how we can analyze this? There are two methods. One is DFT view and then another one is filtering view. So in order to find out the spectrum, how the spectral contents are changes with time, we use the STFT. So the correct option is B. Another one is the STFT is used when you are short on time finishing a project and need a Fourier transform that runs very fast. No. The STFT is used to speed up or shorten time in a signal so that it plays back faster than it was recorded. So this was not correct. So correct option is B only. Okay. Okay. Moving to the next question. Which of the following is the filter bank summation constant? Option A, window length and W less than equal to n, window length and W greater than n, decimation factor L is greater than n of W, that is window length. So which of the following is the constraint for filter bank summation method? So anyone can want to answer this question? What is a constraint for filter bank summation method? Yes, yes, so that is correct. So window length and W less than equal to n is a constraint for filter bank summation method. Okay. So yeah, moving to the next question. STFT analysis of a speech segment is required for noise reduction. So for what we are going to do a STFT analysis for noise reduction. If the STFT analysis is done based on a Hamming window of length 20 milliseconds, here we use window function as Hamming window, and length of that window function is 20 milliseconds. Determine the maximum possible temporal decimation factor, that is L, so that signal is completely invertible when the sampling frequency f of s is 16 kilohertz. 16 kilohertz. So how we will get the decimation factor? So already you know that, I think you have gone through the bandwidth of for Hamming window is 8 pi divided by length of the window function NW, and that decimeter factor is varies from must be less than equal to 2 pi by bandwidth, or this, if we will put that bandwidth value, that is V value from here, that is 8 pi divided by NW. Pi will be cancelled 4, so we will get NW divided by 4. Okay, so now, but how we can solve this question? So Fs is 16 kilohertz. For one sample, what will be the, for one sample, what is a 1 by 16 kilohertz, right? And in order to find out for 20 millisecond or 1 millisecond, you can say that for 1 millisecond 1 by 16 kilohertz, and for 20 millisecond, that is millisecond. So was 1 by 16, or no, we can't find like this. STFT analysis of a speech segment is required. So sampling frequency is given if s equal to 16 kilohertz. So how many samples will be there for 20 milliseconds? Okay, in order to find out the number of samples in 20 milliseconds, we multiply these two, then the number of samples we will get in the 20 milliseconds. Number of samples in 20 milliseconds, and that is 20 10 to the power minus 3 into 16 10 to the power 3, that is 320 samples we will get. Okay, so this is, we are going to find out for Hamming window. So that Hamming window, the number of samples must be divided by 4. So if we, that is NW divided by 4, so in one there is 320 samples. So for 320 samples, that will be the divided by 4, that will be the come 80 samples. In order to completely invertible signal, in order to find out the completely invertible signal, the decimation factor minimum will be the 80 samples. So the correct answer is C. Okay. So have you got this question? How you will solve? As you know that for a rectangular window, the bandwidth will be 4 pi by nw, right? And for Hamming or Hanning window, that is a 8 pi by nw. So decimation factor or L must be 2 pi by b, that is equal to nw divided by 4. So first we need to find out the number of samples in 20 milliseconds. Then in order to find out the decimation factor of a Hamming window, we divide that by 4. Then we will get 80 samples. Okay. Okay. So moving to the next question. I hope all of you got that question. Okay, great. Okay, moving to the next question. A long signal x of n is frequency analyzed using the rectangular window of length 40 milliseconds, where the length of the rectangular window, that is nw, is given 40 milliseconds. If the x of n is digitized using sampling frequency f of s is equal to 8 kHz, determine the maximum frequency resolution of the analysis. So how we will get the maximum frequency resolution? So already you know that what is the formula for resolution? That is sampling frequency divided by length of the window function. Okay. So first here we need to find out for 40 milliseconds. So first we need to find out sampling frequency is given 8 kilohertz. So in the, then if we change in the time, then what we will get 8 kilohertz 1 by 8 kilohertz, that will be get 0.125 millisecond. So for 0.125 millisecond, there is one sample. For one sample, the time required 0.125 millisecond. Okay. Then for 1 millisecond, how many samples we will get? That is 1.0125 samples, right? Then in order to find out for 40 milliseconds, 0.125 multiplied by 40, how much it will come? 1 divided by 0.125, that will get 40 milliseconds. So 8, that is 8, right? And 40, that is 320 samples. And Fs is given 8 kilohertz, or you can say that 8000 hertz divided by number of samples, that is 320. Then we will get 25 hertz. So here a long signal x of n is frequency analyzed using the rectangular window of length 40 milliseconds. Then in order to find out the maximum frequency resolution, this you can get it. In order to find out in hertz. Yeah, someone is. Yeah, you can 8k divided by 320. Yeah, correct. Bhagya. Yeah, please carry one calculator so that enable to you can solve this question right now. I hope all of you solving with me also. So have you got this question? Everyone can got? Okay, great. Okay, so moving to the next question, that is an image represented by a Willow matrix, that is this one, using the density function defined in equation 1, that is equation 1. Determine the value of Ci 00 and Ci 11 at 00 at 11. We need to find out the values of this DFT function. Okay, now we need to take some more calculations. So please carry one calculator. So here it is also 3 cross 3 matrix. So here n is equal to 3. It is a 3 cross 3 matrix. So n is equal to 3. Okay. So in order to solve this question, we need to take another slide, one more slide. Okay. So let's solve this question. So first we need to take what is the value of C. We just need to write down what is the function Ci comma j. I comma j. The function is 1 by root 2 n ki kj. I'm writing like this, please understand, because otherwise we can't able to complete in one slide. X is equal to 0 to n minus 1. Y is equal to 0 to n minus 1. I x comma y cos 2x plus 1 I pi divided by n. This is not a whole bracket. This is I and pi. Cos 2y plus 1 j pi divided by n. Okay, this is the whole function I comma j, I comma j. Now here n is 3. N is 3. How we will find ki and kj? That is given. That is 1 by root 2 for I comma j is equal to 0 or n is equal to 0 is given, and else n is equal to 1, it is 0. So here we need to find out Ci 00 and Ci 11. So for Ci 0 comma 0, 1 by root 2 n. So n is 3, so that is 2 into 3. ki and kj value at 0, 1 by root 2. So 1 by root 2, and for kj 1 by root 2. Then summation x belongs to 0 to n minus 1, that is 3 minus 1, that is 2. Y also varies 0 to 2, that is n minus 1, 3 minus 1 is 2. I x comma y cos 2x plus 1. Here n is 3 and I is 0. Here we are getting I and j. So I and j both are 0. So the whole function again will be 0. Cos 2y plus 1 into j pi. So j is 0 and 2 pi divided by 3. So what we will get 1 by root 6, that is 1 by 2, 1 by root 2, 1 by root 2 is 2, right? X 0 to 2, y also 0 to 2, I x comma y. Cos 0 is 1. Here all the function is 0, cos 0 and cos 0. So that will be the 1 only. 1 by 2 root 6. Again cos 0 is 1. Let's take 1 by 1 summation. So x varies 0 to 2. First we are taking the internal summation, that is for y is equal to 0 to 2. So I summation of all the components. So x is constant, so x will be x only. 0 plus I x comma 1 plus I x comma 2, right? So previously already we have solved this type of question. This is nothing but the summation of all the components. Here we will put x equal to 0 to 2 at every and each iteration. So I first we will put x at, in this equation x is equal to 0, then 1, then 2. So when we are putting at 0, so 0 0 I 0 comma 1 plus I 0 comma 2. Then again we will put here 1 I 1 comma 0 plus I 1 comma 1 plus I 1 comma 2. We have put it 0 and 1. Then again we need to put 2. So I 2 comma 0 plus I 2 comma 1 plus I 2 comma 2. So what is this? This is I00 plus I01 plus I02 plus I10 plus I11 plus I12 plus I20 plus I21 plus I22. This is nothing but summation of all the components of that image part, uh, the matrix. So this is that matrix from where we need to find out that. So this is I00, this is I01, I02, 10, 11, 12. This is so summation of all the components. So what is I00? 8, I01 2, I02 4. And what are the I10, 11 and 12? 6, 7 and 8. 6 plus 7 plus 8. Then next values are I 20, 21 and 2, 9 to 0. 9 plus 2 plus 0. Right? You can see this. That is I20, 21 and 22. 9 to 0. So 1 by 2 root 6 summation. What is the summation of all this? 8 to 10, 14, 20, 27, 37 plus 9, 4, 6. Summation of all these numbers are 46. So if we cut it down, 23 divided by root 6 we will get, right? So what is the value of the I00? 23 root 6. So from where we are getting this one, option A, 23 divided by root 6. Now next we need to find out the value of the I11, that. So again we have to put at the place of I and J, that is 1 and 1. Then we need to again solve like that. Okay, so let's put it here. I comma J. First we need to write it down, otherwise we can able to solve this. 1 by root 2 n k I k j x is 0 to n minus 1. Y is also varies from 0 to n minus 1. I x comma y cos 2x plus 1 divided by n. I pi into cos 2y plus 1 j pi divided by n, right? Okay, so now we put I 1 1 at I and j is equal to 1 1. So guys, are you getting this question? Can anyone answer it? Are you able to understand how we are solving or how we are moving with this question? Are you solving with me? So here also 2 n is 3, so 2 multiplied by 3, ki and kj. So here I and j is 1, right? So at n is equal to 1, what is the value of k of n? Let's see that. At k is equal to n, and that value will be the 1. For n is equal to 0, that is 1 by root 2, and there is missing L at n is equal to 1 is otherwise it is 1. So k of 1 is also there. Then summation x varies 0 to n minus 1, that is 2. Y is also varies 0 to 2, right? I x comma y. Now we will put the values of I and a in this cos function. So after that I am writing here, okay? Cos 2x plus 1. I is equal to 1, so pi only left, because multiplication of 1 will be the pi only, 1 into pi, and n is 3, so 3. Then cos 2y plus 1. Here j is also 1, 1 into pi only, divided by 3. Okay, so ci 1 comma 1, 1 by root 6, and these values are 1, so 1 will be 1 only. So x is equal to 0 to 2. First we will put the values of y, then we will put the values of x in that equation. Okay, so this is summation of all the components. So we will put y varies from 0 to 2. First we will put 0, then 1, then 2. So I x comma 0, we are putting here first 0. So cos 2x plus 1 y divided by 3. Here if we are putting y is equal to 0, then what we will get? Cos, here we will putting 0. So that will be the 0. So what left? Plus 1 only. So cos pi by 3. Right? Oh, just a minute. Here in the equation that is 2n, right? So here it will not affect because the whole part is will be the 0. But here will the values will be the 6 2n because of, okay, so that will be the 6. Writing it correctly. That is 6, 6, 6 and 6. Okay, in the equation can see this is a 2n not a n, so 2 into 3 6. There is a no difference because the whole part is getting 0 cos something here 2n, so cos 0 and cos 0, so it is correct, first one is okay. Okay, so we have put it I y is equal to 0. Now the next value is I is equal to 1, so plus. So yeah, anyone want to say something or ask something? Okay, no. I x comma 1. Now we are putting 1. Y is equal to 1 cos. So x will be the constant only. So x plus 1 pi by 6 here. If we putting in this equation, remember that one. So here we are getting y is equal to 1. So 2 into 1. 2 plus 1. 3 pi by 6. So 3 pi by 6. What is it? 3 pi by 6? That is pi by 2 only. Correct? Okay. Now we will put y is equal to 2. So cos 2x plus 1 pi by 6 cos, here we put y is equal to 2. So 2 2 is 4 plus 1 5. 5 pi by 6. Okay, right? Now we have put it all the values of y. Now we need to put the values of x. So 1 by root 6. Now summation of all the x components. So we will put x is equal to, in this equation x is equal to 0, then 1, then 2. So this will be the very large equation. So please concentrate here, otherwise we will get misplaced. Okay, first we will put in whole equation, in this long equation x is equal to 0, then 1, then 2. So I 0 comma 0, if we put x is equal to 0, so 0 comma 0. If here we will put in x is equal to 0, so 2 into 0 0. So here we will get cos pi by 6, right? Cos pi by 6, and here pi by 6 is there, cos pi by 6. Now we will put in this one plus, here x is equal to 0, So I 0, comma 1. In this equation here we will be putting 0. So 2 into 0, 0 plus 1. So 1 pi by 6 cos pi by 6. Already we have cos pi by 2 in multiplication. Now next we will put I in this equation. X is equal to 0. So 0, comma 2 multiplication with cos. Here we are also putting x is equal to 0. So 1 only. So cos pi by 6 plus multiplied by cos 5 pi by 6. Now in whole equation we will put x is equal to 1. So what will become? I 1 comma 0 here. 1 comma 0. With this multiplication will come. After that here I am writing cos. Here we will put x is equal to 1 in this equation. Remember here in this place. So if we put x is equal to 1, what we will get? 2 into 1, 2 plus 1, 3 pi by 6. That is cos pi by 2, right? Multiplied with cos pi by 6. Pi by 6 is already available. Now we will put here x is equal to 1. So I 1 comma 1. Here we are putting x is equal to 1. So 2 plus 1, 3 pi by 6. Again cos pi by 2, cos pi by 6, right? Then move to the last one. I 1 comma 0, 1 comma 2, sorry, 1 comma 2 here. And again we will get, what we will get? 2x plus 1. So 2x is 1, 2. So 3 pi by 6, that is cos pi by 2. And cos 5 pi by 6. Now we have put in x is equal to 0 and 1. Now we will move to the x is equal to 2. There are very less place, so we'll try to write after this. Let's see. So I 2 comma 0, here we are putting in this equation, in this. Are you able to recognize from where? In this one. X is equal to 2. So I 2 comma 0 in the with this multiplication of cos. Here we are putting x is equal to 2. So 2 to the 4. 4 plus 1, 5 pi by 6. Okay. Cos 5 pi by 6 multiplied by cos pi by 6 plus I 2 comma 1 in this equation multiplied with cos. Here we are putting x is equal to 2. So again 5 pi by 6 and cos pi by 2. In the last one I 2 comma 2, right? Cos, so again multiplied with this pi by 6, sorry 5 pi by 6 and cos 5 pi by 6. So here some is pi by 6 will be there. So I am reviewing now this equation so that we can analyze in this. We can write it here only, otherwise we move to the next slide. So we can't able to remember all those things. Already we have used these equations. So okay. So now what are the different values of 1 by root 6 in bracket? So now here see I 0 0. What is the value of I 0 0? That is 8. 8 multiplied by, just a minute. So 8 multiplied by cos pi by 6 and cos pi by 6. So can anyone tell me what is the value of cos pi by 6? Cos pi by 6 means what? That is cos 30 degree. So what is the value of cos 30? That is root 3 by 2, right? So root 3 by 2 and again cos pi by 6. So it is also root 3 by 2. Okay, so 8 multiplied by that is 0 0 cos pi by 6 cos pi by 6. Now moving to the next step I 0 comma 1 cos pi by 6 cos pi by 2. So cos pi by 6 we have already calculated, the value is root 3 by 2. And what is the value of cos pi by 2? Can anyone tell me what is the value of cos pi by 2? Please answer in the chat box. That is cos 90. So what is the value of cos 90? That is 0, right? So this part will become 0. This part will become 0. And wherever the cos pi by 2 is there, then that part will become 0. Okay. So let's see where is the pi by 2. So here it is also 0. Here is also 0. It is also 0, right? Now, and this one will be also 0. Now it is easier to write. Okay. So moving to the next step, this part is 0. Now what is the value of I 0 comma 2? That is plus 4. I 0 comma 2 is 4. Please see in the that matrix, that is 4, right? I 0 comma 2, this one. So 4, and what is the value of cos pi by 6 and cos pi by 5 pi by 6? Pi by 6 is root 3 by 2. Let it be cos 5 pi by 6. Okay, so we have calculated I 0 comma 2, this one, and this part is 0. I 1 0 is 0. I 1 1 is, this part is also 0. This part is also 0. Now what is I 2 comma 0? What is the value of I 2 comma 0? Let's see. This is 9, right? So plus 9 multiplied by I 2 comma 0 cos 5 pi by 6 or cos pi by 6. So root 3 by 2 cos 5 pi by 6. Okay. Okay, it is done. Cos 2 comma 1 is also 0. And now this is I 2 comma 2 cos pi by 6 cos into cos pi by 6. So let's see what is the value of I 2 comma 2. I 2 comma 2 is already, the value is 0. So the whole function will be the 0. So that means this will also 0. Okay. So I think all components we have taken. So let's see I 1 1. This is a value of 1 by root 6 bracket. So this will be over the 2. So 2 root 3 is 3. So 6 plus here 2 root 3 cos 5 pi by 6. Here 9 root 3 divided by 2 divided by 3 cos 5 pi by 6. Okay. So let's try to solve this. 1 by root 6, then 6 plus, this is cos pi by 2, so we can add this, 4 root 3, so 4 plus 9, 13 root 3 divided by 2 cos 5 pi by 6. So now you can solve it further, or otherwise if we multiply on in this, then we will get 6 by root 6 plus 13 root 3 2 root 6 cos 5 by 6. So you can solve it, otherwise you can leave it here. So let's see. So this is here, it is a wrong answer is given. Here we have didn't have root 3 by 2. So here is a no options are correct. Here must be root 3 divided by 2. Root 3 divided by 2 must be considered in this part. Okay, so no option is correct here. Okay, so this type of problem you can solve like this. So have you got this question, or you have any confusion? Please answer so that I can move to the next question. So can I move to the next question? Okay, so moving to the next question. So if the DFT is applied to the image as in equation number 12 or question number 12, sorry, determine the number of real multiplications required for that. So how many real multiplications are required for the previous question? For that question, we have taken the two values Ci00 and Ci11. So number of real multiplications, as you know, that required is in DFT, number of real multiplications required, number of real multiplications required. I'm writing in the short form, that is 4n square, right, for real multiplication. So here n is 3. In the previous one, n is equal to 3. So 4 into 3 square. So that is 36, right? Here we have calculated for two points, two values Ci00 and Ci11. So total number of real multiplications required for both Ci00 plus Ci11. So for both 36 for this, 36 for this, right? So total number of real multiplication required for question, the above question, that is 72, right? Have you got this question, or you have any confusion? Okay, so we can move to the next question. Which of the following transform is most widely used form for lossy image compression? Option A, two-dimensional discrete Fourier transform. Option B, one-dimensional discrete cosine transform. Option C, two-dimensional discrete cosine transform. And option D, two-dimensional short-time Fourier transform. So here it is given is lossy image compression. So image is given, so that must be a two-dimensional image is two-dimensional signal, right? So first that must be two-dimensional signal. So option B is discarded. So two-dimensional discrete Fourier transform we can use, but it is not a real, and it is used for compression image compression technique. But two-dimensional discrete cosine transform is most suitable for the image. Already we have solved this type of this related to two questions for BCT, which has been applied on the image. So two-dimensional discrete cosine transform is the correct option for this. Discrete cosine transform signal is used for lossy image compression. Okay. Okay. So moving. So clear? Can we move next question? Okay. Already I think we have solved this question. So can any one of you answer this question? Which one of the following is disadvantage of DFT? What is the disadvantage of DFT? It is a complex and has poor energy compaction. Option B, it is real and provide good energy compaction. Option C, it is a complex and has better energy compaction. In the previously, we have seen that DFT is a complex signal. It carries both real and imaginary part, while in the DCT, it is only considered the cosine term that is real. So, DFT is a complex signal and it is not carry the energy of an individual pixel, so it has a poor energy compaction. So option A is the correct answer for this question. Okay. Okay. Moving to the next question. The frequency domain analysis of the signal x of n is equal to 6 cos 0.2 pi n plus 15 cos 0.4 pi n is done using rectangular window of length L. The frequency components of the signal are resolvable for which of the following window length L, where sampling frequency is 16 kHz. Sampling frequency is given, that is 16 kHz. Here the window function is given this rectangular window, and the signal is given 6 cos 0.2 pi n plus 15 cos 0.4 pi n. So already you have seen in the slide of a long signal DFT analysis. So where if the signal has two frequency components, then how we will find it out? The window length, that is given W2 minus omega 1. This is omega 1 minus omega 2 must be equal to 2 pi by L, right? Already I have shown this formula in the previous one. You can see here in this slide, that is omega 1 minus omega 2, or omega 2 minus omega 1 must be less than equal to 2 pi by L. In order to find out the exact sampling rate, it must be equal to. Okay. So here, what is the value of omega 1 and omega 2? First, we need to find out that one. Omega 1 is here, you can 6 cos 0.2 pi n. So what is the omega n? 1, that is 0.2 pi. 0.2 pi. And what is the value of omega 2? That is 0.4 pi. because it is in the form of cos omega 1 n plus cos omega 2 1 n. So you can put 0.4 pi minus 0.2 pi must be equal to 2 pi by L. Okay, so what will we get? 0.2 pi equal to 2 pi by L. So L is equal to 2 pi divided by 0.2 pi. So pi will be cancelled. Then we will get 10. The window length will be the 10. Okay. So option A is the correct answer because option A is matching with this answer. Okay. So have you got? No. How is that possible? What is if? What? Okay. There must be some changes. In this only we will get only 10, not 20. How we will get 20? Yeah, maybe. Yeah, yeah. I have got only 10 only. So I also have got. Yeah, yeah. It is given. Why it is given in bracket. So it is if there is any use, then you can use it. That's why it is given. Okay. So moving to the next question. Perfect reconstruction of x of n from x of n omega is possible using filter bank summation method under which conditions? So, what are the conditions for filter bank summation method in order to find out the perfect reconstruction? So, option A is W of n, that is a window function, is a finite duration window, and x and W is sampled properly in both time and frequency. Option B, STFT is computed for every sample, and x of n omega k is known for all some frequencies. And option C, W of n or is in infinite duration window, and x n comma w is sampled properly in both time and frequency. Option D, exact reconstruction of the input is possible with number of frequency channels greater than the required by the sampling theorem. So what is the correct answer? So W of n, that is a window function, must be a finite duration signal. So all the window function is a finite duration signal. So first we need to see W of n is a finite duration signal, and that x of n omega, that is n, and this is omega, must be sampled in both time and frequency. Already it is a given in the first try. So correct answer is A, that is W of n, that is window function, is must be finite duration window, and x of n omega must be sampled in both time and frequency. So option A is the correct answer. Okay. Okay. So moving to the next question, which of the following window function provides better frequency resolution? Option A, rectangular window. Option B is Hanning window. Option C is Blackman window, and option D is Hamming window. So rectangular window is the most widely and common used window function, and it has a better frequency resolution. Okay, so option A is the correct answer for this question. The rectangular window function provides better frequency resolution among all the window functions. Okay. Okay. So moving to the next question, that is short time Fourier transform is computed for a speech signal sampled at 16 kilohertz. That is sampling frequency is given 16 kilohertz. The length of the analysis window is 20 milliseconds. For analysis of window, the length is given. You can say the NW is 20 milliseconds. And DFT length, the length of the DFT is given 1000. If the above STFT is computed using uniform band pass filter using filtering wave of the STFT analysis, then determine the bandwidth of each filter and center frequency of 30th filter. So what is the bandwidth of each filter? How will we get the bandwidth of filter is defined by sampling frequency divided by the length of the DFT signal. Okay, so sampling frequency is given 16 kilohertz, that is 16,000, and N is given 1000. So we will get the 16 hertz here. Okay, this is, that means each signal has at n is equal to 0, that is 0, and other, that is 16, and the other, that is 32, other, that is 648. Like we need to find out the at 30th. So the center frequency of 30th filter will be at 30th. So what will be the center frequency at 30th filter? So that we will get 16 at, what is the frequency at every, what is the center frequency of every filter is 16 hertz. The length of the every filter is 16 hertz, to 16 multiplied by at 29, because we are considering 0 to 29. 0 is also, so that we will get 16 into 29. Can you measure this? That we will get 464 hertz, right? And what is the bandwidth of each filter? How we will get that? That must be 464 is okay. The 50 hertz. Just a minute, I forgot. Determine the bandwidth of the each filter. So what is it? That will be 16 hertz and the 16. So just a minute. Hmm. So I will look at this. I'm not getting the how it is a 50 hertz. So any one of you know if you are able to solve this, then let me know. Otherwise, I will solve this problem. That is that the center frequency at 30th filter is 464, but for 50 hertz, I'm not sure. Okay, so we'll let you know. Just need to calculate. Okay, I forgot to calculate this one. I will calculate it. Okay. So option B is the correct answer. The center frequency at 30th, that is 464 hertz. Okay, can calculate it. Or I think that may be a correct answer. The center frequency 16 divided by 2, that is 8 hertz, maybe that will be the option A, may be the correct answer. Okay, I will confirm it and will let you in the next class. Okay, yeah, okay. Hopefully option A is the correct option, because bandwidth, this is this window function they have used. Window function is not given, so if it is a rectangular, then must be bandwidth divided by 2. So here 16 divided by 2, then we will get 8 hertz. If other window function is there, then band or Hamming window, let's see what is it. For Hamming window, there is one formula is there, and W divided by 4. So length of the 20 into 16, so 320 divided by 4. So 20. No. Option A is the only correct answer. Okay. If we are using the rectangular window, bandwidth divided by 2, that is 16 divided by 2, 8 hertz. Okay, so moving to the next question. A signal x n k is the STFT of a signal x n of n, and analysis is decimated in time by a factor L, where W of n is a non-zero over its length n of W. X of n is invertible for which of the following conditions? So x of nk is the STFT signal of x of n of s, and analysis of a decimation time by a factor L is given, and where W of n is a non-zero over its length n of W. Wn and the length of is non-zero function, then x of n is invertible in which of the following conditions? First one is a temporal decimation factor L must be less than equal to nw. Okay, this one is correct. L must be less than equal to lw, that nw, that is length of a window function. The frequency sampling interval 2 pi by n less than equal to 2 pi by n w, that is the length of the window function, that is the length of the DFT n. And the temporal decimation factor L is greater than n of w, that is length of the window function. The frequency sampling interval 2 pi by n must be greater than equal to 2 pi by nw. So which one of the correct answer? So the temporal decimation factor L must be less than equal to nw, and the sampling interval 2 pi by n must be less than equal to 2 pi by n w. Okay, so option 1 and 2 is the correct answer. From here, in the these two conditions are correct, so option B is the correct answer. That is option conditions 1 and 2 are the correct. Okay, have you got this? I think this is a theoretical question. In the slide it is already given the temporal decimation factor must be less than equal to the length of the window function, and the frequency sampling interval 2 pi by n must be less than equal to 2 pi by n w. Okay, so these are the questions for this week. Have you have any doubt? Yeah, someone is asking something. Yeah, see, it is given in the slide. So option B is the correct answer. First and the second condition is correct. So any one of you have any doubt? So let me know. Otherwise, we can close this session. So these questions are, frame rate. Okay, which one? Oh, okay. I need to see actually. Maybe it will be there in the website, right? Okay, I will see and will let you know if you have, so I can try here also at sketching. Okay, okay, sure. I will try to get that question also. Okay. Uh, Sirisa, is that helpful for you guys? Is that questions are matching with your assignment questions, or it is helpful? Okay, then great. I mean, it must be helpful while because it is for that only. So, if you don't have any doubts, so we can close this session. Yeah, your voice is not. Mm. Yeah, yeah, yeah. Yes, 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 yes. Yes, yes. Yeah, yeah, yeah. You are audible. Please tell. Yeah. This, okay, but mm, oh, is that exact the same question which you are getting this? Yeah, yeah. But these are not the same questions. Same questions are. Oh, okay. So actually, we have told that. Oh, okay. But there, I am actually including the 20 questions for that reason only, so that we can solve the more. Okay, we'll try. Oh, okay, okay. Okay, okay. I will try to. Actually, we have told that we have to solve that previous year assignment questions. After that, we need to explain the previous year assignment question and some questions other than that. So that's why I am including the previous year assignment question 10 that, and 10 I am managing from the topic, some of the topic. Okay, we'll try to include the other than the previous year assignment questions and this year's assignment questions. Yeah, yeah, yeah. Sure, sure. Okay, okay then. Okay, bye. Okay, okay. Thank you, everyone. Thank you, everyone. Yeah, yeah. Thank you, everyone, for joining this session.